Today, we're going to be experimenting with heat. But before we do anything, it's important to know exactly what we'll be discussing. This branch of chemistry is called thermochemistry. First things first, let's talk about heat. Everyone pretty much knows what it is, but in chemistry, pretty much doesn't cover it. We need to know exactly what we're dealing with. Heat is the amount of energy transferred between a system and its surroundings because of a temperature difference in a reaction. That's great, but now we need to discuss what a system and surroundings are. The system is the reaction itself. The surroundings are everything but the system. A boundary is the thing that separates the system from the surroundings. Reactions that have a transfer of energy can be endothermic or exothermic. Endothermic means that the reaction requires or takes in heat. The boundary will be cool to the touch in an endothermic reaction. An exothermic reaction is the opposite of this. An exothermic reaction gives off or releases heat to the surroundings. The boundary will feel warm in an exothermic reaction. An easy way to remember this is that reactions where you're making a bond requires energy, so they will be endothermic. Reactions where you're breaking a bond release heat and is exothermic. So in this experiment, we're going to need 3% hydrogen peroxide, yeast, a plastic cup, a tablespoon, a thermometer, and a timer. Before we get started, we also need to make sure we're ready to do the lab safely. This means wearing long sleeves, pants, closed-toe shoes, gloves, eye protection, and your hair is tied up. First, pour 2 tablespoons of the hydrogen peroxide into the cup. Then, use the thermometer and find the initial temperature of the hydrogen peroxide. My thermometer reads 69.6 degrees Fahrenheit. Then, add 1 tablespoon of the yeast into the cup. Gently swirl the cup so that the yeast can be mixed into the hydrogen peroxide. Keep swirling for 45 seconds, then measure the final temperature of the solution. Now, the temperature is 98.4 degrees Fahrenheit. Since my starting temperature was 69.6 degrees and my final temperature was 98.4 degrees, the system has warmed up or has released heat. I took off my gloves to feel the cup and it felt warmer than it did before. Keep in mind the system is the stuff involved in the reaction, so it's the hydrogen peroxide and yeast. The surrounding is everything not involved in the reaction, so it's the table the cup is on, the air in the room, the house I'm in. You get the point. The boundary is the cup because it separates the system from the surroundings. So what happened to cause this? The hydrogen peroxide is undergoing a decomposition reaction, meaning that it's breaking down into the 2 substances that make it up. The yeast itself is not involved in the reaction. Yeast is a catalyst for the reaction, meaning that it's something that speeds up the reaction. All it does is speed up what's already going on with the hydrogen peroxide and makes it more noticeable. When it's added to the hydrogen peroxide, H2O2, breaks down into water, H2O, and oxygen gas, O2. Because it's breaking down, it's releasing heat, so it's exothermic. This is confirmed by the change in temperature we found, which was the difference between our initial temperature, 69.6 degrees Fahrenheit, and our final temperature, 98.4 degrees Fahrenheit. This means that the temperature of the reaction increased by 28.8 degrees. We can see at least one of the products, or things made by the reaction. The bubbles formed in the reaction are trapped oxygen gas. Thanks for watching, and I hope you learned something new today.